to look at some conceptual problems that deal with forces. So in number 1, it says, an astronaut in outer space, away from gravitational or frictional forces, throws a rock. The rock will, and our choice would be, continue moving in a straight line at a constant speed. And the reason for that is there's nothing acting on that rock to change its motion. So then it says the rock's tendency to do this is called inertia. Because again, we know that inertia states that an object at rest stays at rest, and an object in motion stays in motion unless an outside force acts on it. Number 2 has a picture, and it says the sketch shows a top view of a rock being whirled at the end of a string, and it's going in the clockwise direction, so 1, 2, 3, 4, 5 around the clock. If the string breaks, the path of the rock is, and your answer would be C, because as soon as that string breaks, there's no force holding that ball in the circular direction, and it's going to go off in a straight line. Number 3 says, suppose you are standing in an aisle of a bus that is traveling along a straight road at 100 kilometers per hour, and you hold a pencil still above your head. The relative to the bus, the velocity of the pencil is 0 kilometers per hour, and relative to the road, the pencil has a horizontal velocity of 100 kilometers per hour. Because if someone's standing on the road and that bus travels by, the bus is going 100 kilometers per hour relative to that person standing on the side. You're traveling at 100 kilometers per hour relative to that person standing on the side of the road. And the pencil is also traveling at 100 kilometers per hour relative to the person standing on the side of the road. It would look to you like the pencil is going 0 kilometers per hour because both you and the pencil are inside the bus. Then it says, suppose you release the pencil while it's dropping and dropping and relative to the road, the pencil still has a horizontal velocity of 100 kilometers per hour because there hasn't been a force acting on it to speed it up or slow it down. This means that the pencil will strike the floor at a place directly at your feet below your hand because both you and the pencil are traveling 100 kilometers per hour relative to the road. And then it says, relative to you, the way the pencil drops is the same as if the bus were at rest, because everything is relative. And then it says, how does this example illustrate the law of inertia? The pen started in motion, and since there wasn't a force acting on it, it's going to stay in motion at 100 kilometers per hour. Now let's look at the words mass, weight, and volume. The force due to gravity on an object is defined as weight. The quantity of matter in an object is its mass. And the amount of space an object occupies is its volume. Now we know that 1 kilogram equals 9.8 newtons. So if we have 5 kilograms, we're going to multiply 5 times 9.8, and that would equal 49 newtons. And if we had 98 newtons, we'd have to divide by 9.8 to get to kilograms, and we would get 10 kilograms. And then the next question just says make up your own mass and do a calculation. So let's say that your mass was 100 kilograms. We would have to multiply that by 9.8 to get us our weight of 980 newtons. So then we have a little table. If we have 1 kilogram, and I did the work over on the right-hand side, make sure that you show your work on these conversions, we would take 1 times 9.8, and that would give us a weight of 9.8 newtons. For the apple, we know we've got 1 newton, so we'd have to divide that by 9.8 to get to kilograms, and we get 0.102. We didn't mass our physics book, so we'll just leave that one blank. And if we've got 90 kilograms, we would multiply that by 9.8 to get our newtons, and it would be 882 newtons. Okay, there's a little mark there that looks like a decimal, but it's not. It's 882 newtons. Okay, for number 7, we've got a picture over on the right-hand side there. We've got a girl with a whole bunch of books, and then she's got a wood block and a nail that's being hammered into the block. And the question says, why isn't the girl hurt when the nail is driven into the block of wood? And the reason for that is the block of wood isn't moving initially, so the inertia of the block causes it not to move, or to move very little. An object at rest stays at rest. There's going to be very little movement, so she's not going to be hurt. And then the next question says, would this be more dangerous or less dangerous if the block were less massive? Well, if the block is less massive, it's going to have less inertia, and it's going to move more, so it's going to be more dangerous. If you need to go back and listen to the answers to any of these review problems before your quiz tomorrow, you can do that. Make sure that you're prepared so you can do well.